So as an example of what this graph would look like, so first of all we need to fix t. Again, it's very important when we talk about a smirk or a smile that we fix time. We're looking at all options of the same maturity, and we look at the graph of sigma on a given option, sigma on a given stock. So the stock is fixed and time is fixed. And we have a typical, this would be what would be called a smirk. Kind of looks like a lopsided smile. And typically one looks for a measure of at the moneyness. And in some graphs of this type, what might be graphed is either it could be a function of k, or sometimes it's graphed as a function of the stock price over k, so that the at the money option would have a 1 here. So you can think of it either way, that when you look at as a function of k, the question is where is the current stock price? And if you graph sigma of k as in units of the stock price divided by k, then you can see more readily, because the current stock price is embedded in that calculation, we can see where if k is bigger than s or smaller than s, how the volatility varies with that. If we only look at it as a function of k, we have no way of knowing where the current stock price is. We don't know what in the money and out of the money options are and so forth. A smile is a similar situation, but it would tend to be more symmetric. And what one observes typically is that somewhere around the middle you would have k equal to the current value of the stock. And for in the money options and out of the money options, the volatility will tend to go up. One of the observations that are commonly made in this situation are that the reason there is this skewness in volatility is the fact that for an out-of-the-money option, you could argue that the market maker is making a slightly bigger bet on the volatility estimate than they're making for an at-the-money option. And that's because, in a sense, the market maker is making a bet in the tails of the stock price distribution. If we have go back to the original price models underlying Black-Scholes or the binomial, if we know today's stock price and we're projecting prices in the future, if in fact the current stock price is way in the money, then we're in a sense making a bigger bet about are we actually going to be making a payoff out there or not? And same with if it's out of the money. So some market observers will argue that this skewness will sometimes be a reflection of the fact that for out of the money or in the money options, the market maker needs to build in a little extra conservatism in the sigma estimate because it's relying a little more heavily on the tails of the stock price distribution. One other, the term structure, which again is no surprise. If one looked at a term structure, we would now look at sigma as a function of t. And here now k is fixed. So we look at all options on a given stock that are at the money. K equals the current stock price, say. And a typical pattern is an increasing term structure. In other words, that the estimate or the value used for sigma is larger over longer periods of time. And that's logical and reflective of the fact that longer periods of time entail more uncertainty, and therefore one ought to be more conservative about the potential volatility in the market. One can also observe times when if you're in a very high current volatility period, you can also potentially see a slightly decreasing term structure of volatilities where the market is saying that today's extreme volatility isn't expected to last, and for short-dated options we need to reflect it. For longer-dated options we might mitigate that a bit. There's also a notion of a surface, in a sense, a two-dimensional graph of sigma as a function of both k and t. Because we've observed for a given stock that sigma depends on both k and t, it's natural to think of it as a surface in 3 dimensions. And it will be called a volatility surface. And many of you may well have seen one. And let's see if I can graph a credible volatility surface here in 3 dimensions. So we'll put time here, and we'll put k along this axis. And we're graphing, let's call this sigma as a function of t and k. And so in the plane which includes the k-axis and the vertical axis, there should be, as a function of k, there's going to be a smirk. So let's say that in this plane, for a low value of t, there's a certain smirk, which is to say that for low k, we observe a higher volatility than high k. Typically, it could be the other way as well. And for each one of these, so this is for fixed t. And now what happens to each one of these volatilities as we lengthen the option? And the answer is that they tend to increase. That's the typical volatility term structure. So one would see a surface where each one of these would curve up, and the amount by which they curve up can vary, and you would get a surface potentially like this. If one can, in your mind's eye, see that we have in the k vertical axis, we have a skew, and then if we look at the any plane in the vertical and t-axis, we have a typical term structure where it tends to increase with time. There's now a volatility index that was introduced in 1993 by Professor Bob Whaley from Duke. And this provides investors with market estimates of expected volatility. In other words, the market, this VIX index, actually is an investable contract where investors can go long or short volatility, and it has payoffs based on the actual volatility versus the volatility embedded in the contract. And so we have, this VIX index is computed looking at implied S&P 100 index options, but you can now also take positions on this index and make bets on volatility. So this is a great idea in that we have an index which measures implied volatility on a collection of options on the S&P, but in addition, you have investors that can be taking long and short positions on that index, and therefore it's a way of gathering market intelligence on this important parameter for which no one of us would have any comfort in estimating. And it gives a market consensus, if you will, or at least some information from the market.